In problem number 8, we've got a conducting tube, and the tube carries a charge per unit length of negative lambda. So we have to remember that lambda is representative of charge over length, and there is a line of charge that lies along the axis of the tube with a charge per unit length of positive lambda. So we're going to draw this charge. If it has positive lambda, then it has positive charges in it. And then we've got a tube that has negative lambda, so that will have negative charges along it. And we're trying to derive an expression for the electric field as a function of distance from the center. So let's start with A, and we're doing when R is less than A, which is the inner radius of the tube. So that means that R is just somewhere in this vicinity right here. So we've got our Gauss's law, and it's Q enclosed over epsilon naught. We're not exactly given Q enclosed, but we are given the fact that Q is equal to lambda L, and so our Q enclosed would be substituted in by lambda L, and it's positive. And then we have an area of our cylinder, because our Gaussian surface is going to be a cylinder shape for rods, and that would be E times 2 pi RL. And then all we have to do is simplify. Our electric field, if you cancel out the L, is going to give us lambda over 2 pi epsilon naught R, which means that the electric field is proportional to 1 over R. So that is going to be valuable once we get into our graphing. So this is for part 1. Part 1 of part A. Once our Gaussian circle, so let's change our Gaussian circle this time to a position between A and B. So that's going to be right in the middle of our cylinder, our tube. And so we know that it's a conducting tube, and because it's a conducting tube, that means that there's not going to be any charges inside of a conductor. And we talked about how the net charges end up canceling out to 0, and the electric fields of the positive rod on the inside cancels out with the electric, or the charges of the positive rod cancel out with the charges of the negative cylinder. And so just memorize that if you are inside of a conductor, the electric field is 0. And so right off the bat, I can already start highlighting between A and B. Looks like this. And then when R is greater than B, we need to figure out what our electric field, we need to figure out what our enclosed charge is. And since we have a positive lambda and a negative lambda for the inner rod and the outer conducting tube, we can therefore conclude that the charge would be equal and opposite. And so our equation for part 3 would be Q enclosed over epsilon naught is equal to negative lambda L plus lambda L. They're equal and opposite to each other, so it actually gives me an electric field of 0 as well. So my electric field just kind of continues outward at 0, but what I do know is that in between, or inside of the cylinder, we do have an electric field, and that is an inverse proportion. So it is going to start at some maximum value and decrease to 0 as it approaches infinity. So this is what your graph looks like for part B. What is the charge per unit length of the inner tube? In this scenario, let me kind of show it in this diagram. We know that the line inside the tube is going to be equal to positive lambda L. And so whatever that positive charge is, it's going to be represented in that way. And then the cylinder has two parts to it. The inside of the cylinder is going to attract enough a negative charge to equal it. So the inside of the cylinder is going to attract equal and opposite, so it'll be negative lambda L on the inner circle. And so whatever's left, which we end up noticing that takes all of the extra charge, that we would have zero charge for the outer part of the surface of the tube. So for the inner part, C, we've got inner surface of the tube is negative lambda L, and then for the outer surface of the tube, we don't have any charge because the rod in the middle attracted all of the extra negative charges from the cylindrical tube. All right, I hope that answered your questions. If you have any questions, make sure to contact me and prepare for your quiz tomorrow. Good luck. Bye.